I want to welcome everybody to our first local and open source AI event.
Paris, and we usually run this on a monthly basis, usually in the Bay Area. So if you're ever in the Bay Area, definitely come to one of our events there too. I think we've got an amazing speaker tonight. Got the logos on the page here, and I think I'll just kick it off and hand it to Tim. Tim is one of the co-founders and CTO of Mistral AI, and I don't think I can do him justice. I'll let him come on the stage and pass it to Tim.
So this is about running two different models. Mistral Small Latest, which is our latest edition on our online API, and Mistral, which runs locally on Ollama. This has function calling enabled, so I can give it tools. The tools that I gave are two things that are interacting with Kubernetes, one thing that can list the pods, and another thing that can describe the pods. And not knowing how Kubernetes work, I like to get some help without revealing all of my secret architecture to the Mistral client, even though we also care about your data and privacy. So this uses the online model to figure out which function to call and how to call it. Then the function is executed locally, and I then ask the 7B model on Ollama to explain what is going on. And it works. So how can I help you? Please describe this pod. So this is an Nginx pod in the demo namespace for me. This will call Mistral Small, which will say, run this query. This is the JSON that I wouldn't understand. It's a big JSON. And then Ollama runs locally and will eventually come with an answer at some point if the demo works. Yeah, here it is. I don't know. It's a demo. I didn't want to just run Mistral because I've done it many times, and I'm sure a bunch of you have too. So this is a nice example of, I don't know, mixing and matching different models for different use cases. And function calling is probably one of the super useful things that is underused, and we need your feedback on what use cases are good or not. That's it.
Clearly, this is the coolest place to be tonight. It is so awesome to see such a big turnout. So I am going to be showing one of the models that we've created at Alphabet and then open source to the world. So how many folks here have heard about Gemma? Woo, excellent. Lots of folks. Hopefully you're using it on Hugging Face as well. And Gemma at a glance is a family of lightweight, state-of-the-art models. We have a 2 billion parameter version. It also includes an instruction-tuned version, a 7 billion parameter version, also instruction-tuned, and other variants that you can play with yourself, or play with yourself. No, that doesn't sound right. But regardless, like very, very fun to see what the community has built. I think 3 days after we open sourced it, we saw somebody build an MOE version of Gemma. So it's just been awesome to be able to experience this. This is part of the Gemini family. It also includes Gemini Ultra, Gemini Pro, Gemini Nano, Gemini 1.5, which we just released and which we will see later today. And in performance stats, it's a little bit on par with Mistral 7B. So if you have experience with that, you can probably get started pretty easily with Gemma. We have it on Vertex as well as on GKE. We even see people who like to use it not just with GPUs, but also experimenting with the smaller versions, even on CPUs. It has a very small context window, so this is a limitation. It's text only, it's English only, which is not ideal. You can also fine-tune it to be better at other languages. On Vertex, you can use it via the Model Garden. On Hugging Face, you can deploy it on many different platforms. You can also use it on Kaggle. This is kind of a architecture diagram. I'm speeding through this so we can get to the actual demos. You can use it on TPUs, GPUs, and the smaller versions even on CPU. And now the coolest thing is that I am really jazzed to tell you what it can do for developer productivity, particularly around these code AI features, which is AI as applied to the entire software engineering lifecycle and really giving every human software engineering superpowers. So our Gemini 1.5 model includes 1 million tokens of context length, which is pretty unprecedented. It means, and putting that into real terms, it can take in all of the emails that you've sent last year, all of the text messages that you'll send in a lifetime. And we all send a lot of WhatsApp messages. Hours of video, full text of lots of laws and regulations, all of the calendars, and also entire code bases. And so when you do this, I was a little bit curious about what that might mean for our friends in the Kubernetes community, for our friends over at Ollama, for our friends at Mistral. And so what I did last night was, in the context of Ollama, I uploaded their entire GitHub code base to our Gemini 1.5 kind of AI studio, which you can interact with a number of our models, including fine-tuning them. And then I asked, hi, Gemini, I would like to add a new model to use in Ollama called Mini-CPM, which I'd never heard of before. The README for Mini-CPM and the source code for Ollama are attached. The source code of it is actually, or the README file is actually in Chinese, so it's not even in English. And then I asked it to implement the change for me in the Ollama repo based on all of the information that I shared. It not only told me that I would need to convert the model, it recommended the best link for the model on Hugging Face, which is pretty cool. So if we go and look, you can see the actual files. It told me that I can convert the model myself, gave examples of testing and running it, and it also mentioned that I could download it from something called Model Scope, which I didn't even know existed. It's kind of a collection of other open source models. And it's really, really cool to see that just by uploading the repo, uploading an issue, it can give you the exact resolution that you need, just through all of this magic of long context. And you don't need big models to have long context. You can also make long context out of small models. And so if anybody wants to hack on something over the weekend, I think it would be super cool to take one of Mistral's models, make it understand 200,000 tokens, 1 million tokens, however much, and then test it with one of these use cases to see how far you can get.
Yeah, my name is Patrick, and as Michael said, I'm one of the core maintainers on Ollama. And yeah, I just wanted to share some stuff that we've been working on for the last, I think we've been hacking on it for like 3 or 4 days. Just trying to get to a point where we can allow people to more easily import models into Ollama. We probably get, I'm going to say like 3, 4 issues in our GitHub repository, like every day with someone who wants to import a new model, whether that's a foundation model or whether that is a fine-tune. And some people just want to, they're doing their own fine-tunes, they want to pull their own stuff in. And right now, that process is a little bit convoluted. So we do allow people to import models if they want to bring their own. And we have some documents inside of our GitHub repository that people can go and follow. But as I was saying, it kind of takes a few steps in order to get there. The basic kind of like premise of this is that people usually they'll go to Hugging Face, they'll use GitLFS to pull a model, and then like they'll clone it, and they'll find a model, they'll clone it, they'll download everything, and then they have to convert. We actually use LlamaCPP on the back end for one of our runners, and the way that most of the models that we're using right now, or all of the models that we're using right now, are using LlamaCPP, and they require a format to run, which is called gguf. And in order to get it into that gguf format, you actually have to go and run one of these convert scripts. So this is all outlined inside of the documentation. But there's a lot of different convert scripts that you can do, so it's a little bit confusing to figure out what that is. Once you've gone and converted it, you then have to quantize the model. And I'm actually really curious about this. How many people here actually know what quantization of models is? It's about actually, let's go the reverse. How many people don't know what quantizing a model is? Yeah, it's about half. So when we pull a model from Hugging Face, when you get it in PyTorch format or when you get it into safe tensors, it typically comes as a 16-bit, like has 16-bit values for each one of the different weights inside of the model. And so what quantization is it's just cutting that down to 4 bits. That's it. It's really simple. And it's just It's a really simple algorithm that we need to go and run, but you still kind of have to know what that means. And if you have gone through the different Ollama repositories, you'll see all of these different tags for individual models, which say like Q40 or Q4KM or whatever. Those are just different ways, or different algorithms for cutting those different models down. And the reason why we do that is because most machines, most laptops and GPUs, at least for consumer stuff, they're just not powerful enough to go and run it. So you have to quantize it first. So you've cloned the repo, you've converted the model, you've quantized it. The next thing that you need to do to make this work inside of Ollama is that you have to create a model file. This is kind of patterned after Docker files. I think Solomon's here, so I think it might be Solomon's baby. So you create something called a model file, and the model file, you just specify the thing that the binary that you've just quantized, and you can put other different parameters, the chat template, things like that inside of it, and then you're ready to go. You run a command called Ollama create, you give it the model file, you run that, and now the model is imported. And then you can just use Ollama run, just the same way that you would run Ollama run Mistral or Ollama run Gemma. So what we've been hacking on for the last few days is there a way for us to make that a little bit easier for people? This is not production code. Like I said, we've just been hacking on it for a few days. You can't get it yet, but I thought I would do a demo of it anyways. I have not. I used to work at Docker with Solomon as well too. Solomon's co-founder, or the founder of Docker. We always would do a sacrifice to the demo gods. I don't have anything to sacrifice right now, so I'm hoping that it's going to work. Should be good. OK, so I've gone to Hugging Face. I've actually pulled the Gemma 2B, the small model from Gemma. And what I'm going to do is actually convert that to work inside of Ollama. This is the instruct model as well, too, so we can chat with it, and it should make sense. So I've pulled that down from Hugging Face. It's just sitting in a directory on my laptop. And you can see each of the different safe tensors there. We're going to take those safe tensors, and we're going to try to convert those. So the way that this works is I have a model file that's created for Gemma. And it just has the same path to where I've used git LFS to pull the Gemma model. I specify the template, the chat template that is going to be used for it, and I have some other parameters that come along with this. These are all on the model card inside of Hugging Face as well, too, so it's pretty simple to get them. And now that I've done that, I'm going to do Ollama create. We have a new flag. This is not fully baked yet, but it's pretty close. So we have a new flag called --q. You don't need to use it, but the idea is that we're going to quantize at the same time. And we're going to call it Q40 for the quantization. You'll also be able to specify lots of different quantizations if you want that to work as well, too. And we'll give it the path to the model file. And the last thing I need to do is give it a name. And this is going to, and I'm going to apologize for this. This is a kind of a funky name. I have a copy of the Ollama registry running on my laptop as well, too. Normally, you would never need to put that in. But we'll put that in as part of the name itself. And we'll call it Gemma. And so now what is happening, hopefully if everything works, it's going to go and do those steps, that conversion and that quantizing step. And since this is the 2 billion parameter model, it should only take roughly 30 seconds or so. And it kind of like eliminates all of those parts for you. There we go. So it's created. You can see that it's unpacked the metadata from the safe tensors. It's processed it. It's created it. And now it wrote all the layers out. So I should be able to do Ollama run. And we're going to specify the quantization level again. So that's Q40. And the funky name, again, normally you would never have to put the funky name in, but it's just because I'm running the registry here. And call it Gemma. And that should be it. There it is. So we're loaded up now. Let me just refresh that. And let's ask it a question. So we'll say, why is the sky blue? There we go. Yeah. OK, so one last thing I wanted to show, which was actually today you can go and take a model and you can go and push it to Ollama.com. But I wanted to show how this quantization thing worked as well, too. So I'm going to go ahead and say Ollama push. And I mentioned before that this is running on my laptop. So normally you'd never type this. So we have this insecure flag. I don't have TLS on my laptop, so but never use this flag. So, and we'll specify the quantization again. So we'll just say Q40. And we'll say localhost 6000. And we called it pdevine Gemma. And there we go. We just pushed all the layers up to the registry, which is running. And if I go into my laptop, you can see I have my own namespace inside of this registry. And Gemma was pushed. So if I click on this new flag that's up here, we can go to the quantization. And we can see that that one was pushed. And you can do it for each of those different quantization levels.
We built this product called Dagger. It's a CI product. It runs your pipelines in containers. It lets you break them down into little functions. And then those functions run in containers. And you can connect functions to more functions. And you get this really nice modular system. And then we launched it, and we had an open source community show up, and we've been building it together, and it's been great fun. And then something happened. Our community started saying, hey, we're doing these CI pipelines with Dagger, but we're also, we're shipping AI features. And so now we need to do some AI stuff in the pipelines, and we're using Dagger for that, and it's fun. And then something else happened. I've been talking to my friend Darren Shepard from Acorn, and his co-founder, Sheng, is right here. And Darren has been working on this new tool called GPT-Script. Have you heard of it? They launched it recently. They just pivoted to doing only GPT-Script. And so we're part of this, DevOps people get excited about AI movement, I guess. And Darren, as it turns out, is an avid Dagger user, and he told me, this Dagger function primitive that you guys have, it's actually a perfect fit for function calls in the AI world. OpenAI function call API, and that's what we're using with GPT-Script. And so I encourage everyone to check out GPT-Script. It's a really fun little scripting framework for leveraging this feature, function calls. And so then we got really excited together about combining GPT-Script and Dagger so that every time anyone in the Dagger community writes a Dagger function, and there's a lot out there in the Daggerverse, it's automatically available for a model to orchestrate, so then you can ask a model to do something for you, and you just make this variety of Dagger functions available, all in their little containers, and the AI will, on the fly, assemble a pipeline, the perfect pipeline to achieve your goal, right? By connecting these functions together. So we started hacking on that, and we're not done. But I thought I'd show you anyway, and we'll see what happens. So that's the idea. OK, oh, by the way, I have to say, this is the Daggerverse. You thought it was a joke, but there's actually a product called the Daggerverse. And it's a place where you find all these Dagger functions, and you can do all sorts of cool things. And, of course, there's one called Ollama. So there is an Ollama module. I'm not going to run it, though, because it's going to be super slow on this particular machine in a container. GPU support coming soon for Dagger. There's another Ollama-related module in there. I don't know what it is, but it seems fun. OK, so I'm going to try and now run this other unrelated thing. Also, GPT-Script at the moment relies on OpenAI, but I think the #1 priority of the team is to support local models. So I thought, OK, it's kind of cheating, but not really. So, and I think Mistral is the first one they're trying it on. So I was encouraged to hear you say function calls are underutilized, because I agree. We're going to overutilize them, so I would love to talk to you. I'm sure Sheng would love to, too. Maybe he's found you already. Anyway, OK. So the way you call a Dagger function, you just type Dagger call. and then you point at a module. And the module's right here, so I just type Dagger call. This little module is called Daggy. It's my little AI assistant for running Dagger things. And then I just say do, that's the name of my function. I have to pass a token. You know what, I'm going to cheat and go back in the history. OK, there it is. So dash dash token, you know, soon this will not be needed anymore because we'll have local models doing this. Hooray. And then you just pass the prompt. And so this is a small subset of the Dagger API that's available because we're not done integrating. So you can do things like pull containers, run, you know, picture what you could do in a Docker file, roughly. You can kind of string these operations together. So here, let's see, I said something like, for each of the following container images, run the command, list the contents of this directory, show me the result in a markdown table, you know, and here are the containers, you know, Alpine, Ubuntu, Debian, you know, it's supposed to pull them. So not a super useful example. But imagine something more like, for these 10 repositories, pull all the tags, and for each of these base images, run the Docker file, run the tests, show me all the results, and give me nice green and red emojis, you know, something like that. And boom, you have an awesome test pipeline that the AI is just running for you. And I just want to emphasize, some of you, I think maybe you all got it, but this is not code generation. You're not asking the AI to generate code that does this pipeline. It's dynamically composing a pipeline for you, right? Oh, and it's done? OK, it's done because it's in the cache. I just want to be clear. OK, so I guess it did that. Well, that's a lot of files. Yeah, that's the demo. OK, let me remove something. Or you know what? I'm going to flip Debian, Ubuntu. Haha. Oh, sorry about that. Bigger, bigger. Is that good? Oh, and I was going to set a timer to stay on time, and I forgot because I was intimidated by this crowd here. OK, so it's doing things. You can see all these functions calling each other in parallel. And now we're waiting for the model. And then the model is calling Dagger. Oh, you can see the actual operations. So it figured out, oh, I should probably call this function that pulls an image. The beautiful thing here is the Dagger API it's all GraphQL under the hood, so it's all easy to introspect and explore. So this is really the model exploring an API on its own and figuring out what to do, right? And the beautiful thing, too, is that it's all hooked up to our code generation system. So every time someone in the community writes one of these functions here, so someone said, you know what, today I'm going to wake up and I'm going to integrate with HashiCorp Vault. Oh, and my name is Kyle, and I'm right here. Or with Fly.io or Docker. They write the little module, they push it, and then immediately the model can use it. That's the idea. So the Dagger ecosystem becomes, you know, the playground for the model. And I think here it's a back and forth. We're waiting for, mostly for the model. And it's stitching things together. I guess the local model would be faster, but would it be smarter? Yes. I'm sure the answer is yes. I don't know. I'm waiting on you guys. OK, time is up. OK, imagine it worked. It's the same as before. But the second time, it'll be super fast, I promise. OK, so if you're interested in the topic of function calls and the future of stitching that into a broader software ecosystem, please come talk to me. I'm very interested in that. And go talk to Sheng if you're interested in GPT script.
I'm Ellie. I come from a company called Docker, and I want to talk to you today a little bit about testing. I represent a project called Test Containers. Test Containers allows developers to do integration testing as easily as they do unit testing. A developer can write a unit test, say, hey, before you run this unit test, give me an instance of Kafka, vector database, an instance of MySQL. When it's done, run the test for me, and when the test is complete, delete everything and allow me to rerun those tests over and over again. And what we've been seeing over the last little while is our project is starting to get utilized more and more by developers, application developers, coming from whole walks of life, coming from enterprises, trying to build their first experience, trying to build their first AI experience using models, using Llama, and other things. And the project Test Containers is available in 9 languages now, and there are more coming. I'm going to do a quick demo of spinning up Ollama, this Mistral model. Thank you. There we go. I'm going to make sure that the model is running, and then I'm going to ask Ollama a simple question. Can you help me explain what is test containers? Right? And then I'm going to make sure that when I get the result back, the result contains testing and consistent, because I want to make sure that the result is actually somewhat good. I'm going to click the button over here. What's happening under the covers over here is that I'm spinning a couple of containers over here. All the containers are up and running. I just asked Ollama, this Mistral, for that question. And now it's now doing the inference, and it's going to come back with the result in about less than a minute, I hope. There we go. And my test, oh, there we go. My test has passed, and it has told me that, absolutely, Test Containers is an open source library for testing software, and so on and so forth. And the response did contain testing and consistent. So what if I'm a developer at a company and I say, hey, Mistral model was great. What if I want to iterate, and what if I want to do Llama 2? How easy would that be with that same experience? So with this, I'm going to go and make a change over here. Llama 2, there we go, and Llama 2. Press a button, there we go, live coding on stage. It's going to go and spin up a different container. There's a Llama 2, now it's spun up. It's going to issue the same request. It's going to use a different model to infer a different result, and then we're going to see if our test passes or fails over here. Let's give it a second. Go. Let's see. Suspense. Suspense. It passed. There we go. And it told me that, of course, Test Containers is a powerful tool, and so on and so forth. So this was an easy iteration experience of iterating on an experience using the tools that you already know and love, the languages that you do know and love. Under the covers, what was actually happening over here is that I was using Test Containers, and Test Containers was actually issuing the request through the network over to Test Containers Cloud, which is an edge cloud service that we are running. And we are now running it in preview with GPU support, and that's why it was able to go and run it and instantiate it so quickly and be able to get the results so quickly. Just briefly, we are now, Test Containers is available with over 100 different integrations. We now support a large number of vector databases, including a number of them that are in official module status, which is actual vector database is supporting the module, so Quadrant is the latest one to get added to this list. We also have an Ollama module. Thank you. Finally, if anyone wants to try Test Containers Cloud with GPU support, I have a I have the bit.ly link and the QR code if you want to try it. Thank you.
Hi, I'm Pierre. I'm a founding engineer at LlamaIndex. For those of you who don't know, LlamaIndex is a leading framework for data ingestion into LLM. So what we do, first we do an open source framework, MIT license. You can find us on GitHub, available in TypeScript and Python today. We also maintain something called LlamaHub, which is a hub that contains hundreds of plugins to connect to vector database to do retrieval or to implement a specific parsing strategy for different kinds of files. And we also have an enterprise offering. We have Llama Cloud and Llama Parse, which are a tool to do better parsing for RAG, and a tool to do manage retrieval for big corporations. So what is RAG? RAG, or Retrieval Augmented Generation, is basically the idea that an LLM or OpenAI model, for example, don't know anything or don't know everything about the world around it, and most of the time don't know the specific of your company or of your document. And the idea of RAG is to bring in front of the model the data it needs to take a decision or to answer a question. So basically how it works, you take your data, you ingest it, you chunk it, you index it, generally in a vector database, and then you use some strategy to do retrieval and to select the most relevant piece of data that you want the LLM to use to answer a question or a query. So today I will do a short demo and hopefully it works. I will try to show you how we can do RAG today 100% locally on your machine. And for that I will use LlamaIndex as the orchestration framework, Hugging Face for the embeddings, and Ollama and Mistral for the LLM. So the first thing you will have to do, it works. I'm connected to the internet right now. Is to install LlamaIndex. So pip install LlamaIndex in this case. And sorry, I will zoom in maybe a little. Sorry, zoom in now. Second thing you will do, you will want to serve Mistral, for example, with Ollama. So you will do Ollama pool Mistral or Ollama serve. Ollama serve is very useful. It pops up an Ollama server on your machine, and then you can just query it. It was cached. The second thing you will do, you will go on LlamaHub and you will download the Ollama module for LlamaIndex, and then you will, initialize LlamaIndex. And in the setting, I will specify that I want to use Mistral. With a request timeout of 1 minute. Next, you will want to have something to do the embeddings. So the embeddings is what we use to transform text into vectors. And for this demo, I will use another module from the LlamaHub, so LlamaIndex embedding Hugging Face. And I will download BG, which are quite good embeddings, open source. And once it's done, all my setup is ready. I'm able to do RAG locally on my machine. So I will do something crazy dangerous. I will cut the internet. And hopefully the demo god are with me. So the first things we will do, I have load in a folder here, just one file for this demo, an essay from Paul Graham. The first thing I will do is I will use LlamaIndex simple directory reader. So it's a tool that will find all the files in a directory, will parse them, and will store them into a set of document nodes. So it loads the file, it parses it, it chunks it. Next, I will use the LlamaIndex vector store index. So it will take this document and it will embed it into embeddings using the embeddings we put before. We configure before. This takes around 4 seconds for this document. And then I will expose this vector index as a query engine. And with that, all is in place, and I should be able to ask questions to an LLM, but retrieving the most relevant content related to my query. So if I want to know what did the author do growing up, I can run the query. It takes a little time because Ollama is running locally. So I'm running the query currently. It has used the embedding on the vector store to find the most similar chunk of the document. It had appended them to the query, and then I'm able to answer correctly, ground on fact and not hallucinations. And I can run a second query, for example, how did the author learn how to invest in a startup? And I will be able to have an answer based on the document I provided before. So yeah, this is basically what RAG is. You can do it fully locally. If you want to learn more about RAG, you can find LlamaIndex on LinkedIn and Twitter. And also, next week, there will be the first RAG user group Paris meetup that you can find on meetup.com. Thank you.
This is interesting. and super exciting to have you all here today. First, I want to thank Michael, Jeff, and the complete Ollama team for having set up this event. We've been working on it for a few weeks now, and it's really a pleasure to have you all in this beautiful space. What I'm going to demo you today is like how we can deploy LLMs globally in 5 minutes, and we'll get started. So to give you some context, I'm Yann. I'm the co-founder and CEO of Koyeb. I basically spent the last 12 years building cloud service providers, the last one being Koyeb. And what we do is we provide a fully managed global serverless platform for high-performance APIs and inference workloads. And that's where the LLMs enters. So we are going to deploy Ollama in 6 locations. We have 6 core locations and 250 edge locations. So the Llama are going to be deployed actually in 3 of them, Washington, Frankfurt, and Singapore, and we'll add Paris to the mix. And this is going to take us 5 minutes thanks to the amazing work of the community. So let's do this. Basically, we'll click on koyeb.com/deploy/Ollama, which actually you have all on your badge. It's like what is at the bottom. So we're on the website. We just click deploy, and we'll land on our control panel. So what we can do here, basically we are deploying the Docker Ollama image. We can select the locations. We'll select Washington, Paris, and Singapore. We're running on actually a GPU machine. We are going to try to make it a bit of serverless in it. We're going to set up some basic auto-scaling. And that's basically going to be it. We're going to hit deploy. I need to zoom. And basically, we'll get like the instances showing up here in about like 3 minutes. So we'll get the inference running. So actually, the Paris one was pretty early on. So while it starts, it's going to take about 3 minutes. If the demo works as expected, we can actually use one which is already deployed on this account. So if we go back to this organization, we have 2 apps. The one we just started deploying, which is here, and we have one which is called Global with a service which is Ollama. And so it's actually accessible right here. So it's deployed in Frankfurt, Singapore, and Washington. We see all instances, and we have the public URL here. And what we can actually do is ask this model to answer a question. So I hope you all see this terminal. And basically, if we do a simple request, so we'll ask it the question. So it's a tiny llama model which is loaded. And so we can simply ask, why is the sky blue? And if the network is with me, we get an answer. And so what's happening behind the scene is basically the request is routed to the nearest point. So if you are in the US, you're going to be redirected to the Ollama model, which is running in the US. Right now, we are redirected to the nearest one. And we might know why the sky is blue if we are able to read JSON directly. So that's the principle. And so here we have actually that's the one we deployed earlier. And actually, if we go back, we have this one, which is healthy. So it worked in 2 minutes, actually. And we have exactly the same thing here. So it's an Ollama model running. We have, for instances, running serving this model worldwide with a minimal latency to all our users. And I think that's the main thing I wanted to show you today, how easy it is to deploy in production. And if we go back to our slides, so, I mean, if you can try it, like the model is running, it's live. in production. And we're actually going to provide the exact same experience with specific accelerators. So this demo is running on CPU, so you will have decent performance depending on the size of the model. If you go into larger models, you obviously need accelerators. So we'll be partnering with people who are providing like specific accelerators, which are not necessarily NVIDIA, to not name them. And you'll be able to have the exact same experience with these new players. And I think that's it for today. So if you want to know more, I'm happy to chat about inference. If you want to try it out, we are providing credits for the platform, and I'm happy to chat here on Twitter, and you can find us on koyeb.com.
I'm going to talk about fine-tuning an LLM to make better autocomplete suggestions on your code base using all these tools, which you know, Hugging Face and Ollama, I'm sure. The other two I'll explain. So yeah, just some context. I'll explain how DLT, the company I work for, fits into this later. But yeah, at dltHub, we built a open source Python library that automates data loading and is designed to kind of take away the headache of all the usual like data engineering tasks like schema management, normalization, and so on. But yeah, getting data from A to B easily. And I'll talk about how that ties into this demo later. Yeah, so what is Continue? This is the tool I'm fine-tuned an LLM for. So basically think GitHub Copilot, but open source. So yeah, it has a feature called autocomplete, where as you're coding, it gives you suggestions on what should come next. So you can accept those or reject them. And this tool works with all kinds of different models. It works with the standard ones like GPT-4 and so on, but also any open source models that are available through Ollama. Yeah, and so we were thinking about whether we could use this tool to make even better predictions on our code base by fine-tuning an LLM for it. So yeah, I kind of started experimenting with this. It's still very early stages of the product, but decided to look at Starcarder 2, which is an openly available model. I kind of picked the smallest version of it with just 3 billion parameters, just because it's easier and quicker to train. And then what I did is I trained that on all the code in our open source GitHub repos. Yeah, just using the supervised fine-tuning trainer from Hugging Face and passing the content of the Python files as what should be predicted by this LLM. Yeah, that was, with this model, it only took like from 30 minutes to an hour, dependent on what parameters I was using. And then, once I fine-tuned that, I wanted to share that with the engineering team. So actually, I went exactly through the process that Patrick was talking about earlier with converting the model through to an Ollama-friendly format. So it's nice to hear that there's an easier way to do that now. But yeah, I used Ollama to push that into their model repository so that our engineering team could use it, and got some pretty good feedback for them so far. I mean, we should probably do some proper testing on it. But for now, I can show you just what the model was predicting before and what it's predicting after I fine-tuned it. Yeah, I was going to do this live, but it went terribly during my dry run, so you're going to get some recordings of me doing this instead. OK, so this is the unfine-tuned model. So yeah, I mean, what is in this Python script is a DLT pipeline to load Slack data into DuckDB, so in a database. And I'm trying to write all the functions necessary for that, and you can kind of see that there's there's suggestions from the base model, but they're not necessarily what I want. Here it's actually predicting what you would expect it to predict. But then, yeah, there was a few just things that it could be doing better. Like, for example, there's a start date thing where it just picks a random date where it should be passing the parameter up there. And so what this looks like after fine-tuning, after I fine-tuned the model, you kind of immediately get more accurate predictions there. So it's directly predicting that this should be a DLT pipeline, since this is importing the DLT package, and we want to create a data set out of that. So yeah, we have some more accurate predictions there. There's still some weird things, like the indentation is off. I don't know if that's because our code base has weird indentation, and sometimes it predicts random comments, which maybe it's just overfit on our code base. So that's still something to figure out. But yeah, so far we've had some nice results. Our engineering team said it's been a bit more accurate on their code as well. And so that's one thing we've done and we'll explore further. But the other thing we were thinking about is like, how useful is it just fine-tuning the model on our code bases versus data from the Continue tool. So Continue actually dumps like the usage data into a JSON-L file. Based on whether you accept a prediction or not, all that data is stored in this kind of JSON-L format. So you have here the prompt that the model saw and the completion suggestion it had, and then whether you accepted it or not. And so we thought we could use this data to further fine-tune the model. Yeah, using the DLT package, I kind of built a custom pipeline there where it takes this JSON-L file, loads it line by line, only takes the data I actually want. So I only want the accepted prompts for my fine-tuning, or the accepted completions for my fine-tuning. And then internally within DLT, it converts that into a Parquet file. And then I built this custom Hugging Face destination where it basically just uploads all that data via the API into a Hugging Face data set. And yeah, so that data set just looks like that then. You just have the prompt and the completion, and then you can use that to fine-tune the model further. We didn't actually I didn't get to that part for our code base yet, because I still need more data from our engineers, but I think that'll also work pretty well. That's all. So if you want to see the code of that, then you can scan that. Thank you.
Cool. Hi, everyone. What an amazing event. It's really cool to be here. I'm going to talk about a new feature that we just launched, that we're launching like right now. This is the launch of it. So I would like to announce Helix Tools. So Helix Tools is the ability to call any API from a local open source LLM that's running in Ollama. So the best way to explain it in more detail is to show it to you. I'm going to start by, here we have Helix. It looks a little bit like another chat interface you might know that I won't name. And what you can see is that we've added the ability to plug in APIs to your chat sessions. And so we've got a couple of APIs here. We've got a products API and a hiring pipeline API. Because I think it's quite interesting to think about when you've got local private LLMs, how you can connect them to your business systems that have private data in them. So we're going to connect this LLM to a products API and a hiring pipeline API. And then I would please like everyone to pray to the demo gods for me. So in the hiring pipeline API, we have information about candidates and the jobs that they're applying for. And I happen to know that one of the candidates is called Marcus. So let's say, what job is Marcus applying for? Oh, OK. He's applying for a human resources manager job. Well, the products API is actually an API that I can use to buy laptops. So should we buy Marcus a laptop? Yeah? OK. So what laptops do you have or are there available? Let's see what it says. OK, so it's gone to the laptops API now because it identified that it was a question about laptops, and it constructed the API call appropriately. And it's given me a list of 3 laptops. So let's see if we can get some intelligence out of the system. What laptop would you recommend to buy for Marcus, given his job role? Let's see what it thinks. OK, it suggests the mid-range one, and it gives a good reason. Cool. So I'm just going to say purchase that laptop and send the receipt to luke@helix.ml. Cool, it did it. So here we have a local model running locally on Ollama that's connecting to an API based on the Open API spec. So the next part of the demo is I'm now going to automate programmatically interfacing with the Tools API using Dagger. So I'm just going to do a simple call. So there's a Dagger module for Helix that we wrote because we want to be able to test Helix, and Dagger makes it really easy to test it. So I'm going to ask what laptops are available, and there we have it. We're able to make the same calls using the Dagger module. And I can show you, for example, that I'm going to try and grep out. I'm not going to show you my secret key, but I am going to show you that we've got a list of active tools enabled for that module. So it worked. So that's integrating an LLM, running on Ollama with corporate APIs, and then also showing that we can run that from Dagger. Let's dig in a little bit quickly. I know we haven't got long, but let's dig in quickly to what we just saw. So what we have is we have some corporate APIs. In this case, on the left-hand side, we have the API for buying laptops. And on the right-hand side, we have the API for looking at the job vacancies and candidates that have applied to them. Of course, these are just demo APIs that we built, but you can imagine integrating very easily with your own and whatever APIs you need in your business. You just copy the Open API spec into Helix. Helix picks out the different endpoints that it can call. And then we have this technique where the prompt goes to the control plane, and the control plane kind of wraps that prompt in another prompt. So for example, this prompt here says, you are an AI tool that classifies whether a user input requires an API call or not. So that's the first step, is you classify the prompt to determine whether or not you need to use tools, and if you need to use tools, then which ones to use. And then there's a second step, which is, given that we've selected a tool, there's another LLM call that would go to like Mistral running in Ollama to say, OK, well, construct that API call for me, and then the system itself will actually make that API call. So the way it works is, what we saw here was the Dagger module, which we can use to test the system, makes the API call to the Helix control plane. Helix runs a clustered set of GPU runners using Ollama, as well as other model runners. And it runs many models on those runners, including Mistral. We're using Mistral, mixture of experts in this demo, as well as SDXL for image generation and things like that. Then the control plane runs through this process that I described. The tools classifier figures out whether or not the model should call an API at all. If it decides that it should call an API and which one, then it builds that API call, and then it actually executes the API call and goes off to the outside world to do things. Just very, very quickly, other things that Helix can do. We can fine-tune text. So this was inspired by LlamaIndex, by the way, so thank you, LlamaIndex. You can take inputs like PDFs, Word documents, API schemas. This is a really interesting one. Some API schemas are very, very big. Convert that into Markdown. Use a language model, in this case Mistral, running in Ollama, to generate question-answer pairs that are used to train Mistral 7b using axolotl, and then it spits out a LoRa file. You can also fine-tune images using this system, using SD scripts or COG SDXL. And then once you have those LoRa files, either for the text or the image models, then just like Neo in the Matrix, when he gets something plugged into the back of his brain, the language model suddenly knows how to do that thing that is encoded in the LoRa file. And so this is an example I made earlier of Fry holding a fish instead of a pile of cash, and how I prompted it. So you can also do fun things with it. So just to recap, Helix is clustered Ollama with multi-user support and a familiar UI. It's multimodal. It supports image models as well. You can fine-tune models. You can deploy it on your own infrastructure with Docker Compose. And of course, it now has tool support. So thank you very much. I'm Luke Marsden. I'm bootstrapping this company. So please reach out to me. And yeah, let's build some cool stuff together. And the Dagger module is available there as well, if you want to try that out. So thanks very much.
OK, great. So hi, everyone. I'm Will from Neo4j, and I'm here to present constructing knowledge graphs from unstructured data. It's meant to be YouTube videos, but I realized unstructured data actually encapsulates more than that. So just so I understand my audience a bit, who here knows who Neo4j is or what a knowledge graph is? Oh, wow, that's a lot. So great. So yeah, I'll speak a bit about Neo4j. We are the leaders in graph database technology. Using Neo4j, you can structure your data into dynamic knowledge graphs. But what is a knowledge graph? So knowledge graphs capture information about entities in your domain and the relationships between them. So if you're a developer, what does that mean in practice? What it means is you define your nodes in your graph to represent your data, and you can have certain properties associated with those nodes. And then next, you define the relationships between those nodes. So now you start getting this really powerful data structure when you have a whole network of nodes. And once you've set up your knowledge graph, you can start asking it interesting questions or explore your data to find cool and interesting properties. And I'm not brave enough for a live demo today, but here is a demo tool where I took this really cool YouTube video I found about the NVIDIA GTC 2024 highlights, pasted it into this link. So this is like an internal tool we have, by the way. And I took this Wikipedia page, put it in as well. And I'm just going to fast forward a bit. So what I did there was I'm starting to generate a graph using OpenAI GPT 3.5 model here. And it brings me to this. Now you can start doing interesting things like visualization of your graph. So what I just did there was imported my unstructured data into my database. Now I'm starting to use this visualization tool, Bloom, to visualize my data. And now I can visualize very interesting things about my knowledge graph. So this takes a while. And yeah, so you can start to see how this can be really useful, because you sort of see there you can see there's NVIDIA. This is all captured from the video and the Wikipedia page, by the way. So you can start seeing there are interesting entities there. Like here, for example, you can start to play around, fit around with the data, try and adjust it to your use case. So I can see NVIDIA announces Blackwell, and then you can even even delete some things that you don't think are relevant for your data. And yeah, what I think is really interesting as well is you can use all these functions and features that are already there in Bloom. And let me skip forward a bit. I think what's really interesting is you can even start to chat with your data. So here I typed, tell me about Blackwell. And this is GPT 3.5, by the way. So it has not seen data from this week, definitely. And yeah, there's some RAG thing going on here as well. So it gave a pretty good reply, I think, not too bad. And yeah, this is it. And feel free to check out the LLM graph builder as well. Yeah, that's it. Thank you.
Awesome. That's it for all the demos today.